Hello and welcome to Unit 2, Lesson 3 on relative velocity. In this lesson, we're going to be working further with adding vector lines together. And for the most part, the questions are going to fall into one of two categories. We're either going to have an airplane and it's going to be flying with or against the wind, and we're going to determine how much the wind affects how it moves. Or it's going to be some sort of ship or a boat moving through a river. And again, it's going to be determining how much the current affects the path of the boat. So to get us established with the system of how we're going to be adding these vectors together, the first example is actually quite simple. And the idea is just to reinforce or introduce you to the idea of how we're adding these together. So the basis of this topic is we're going to be discussing, as it's written in your book here, we're going to have the actual velocity with respect to the ground, right? So you can imagine if a plane is flying through the air and it's flying against the wind, it's going to be going slightly slower than its max speed. So we're going to say actual velocity, and the book has here, right, WRT stands for with respect to. I think there's a little dot in there, with respect to the ground. And we say that is equal to the velocity with no current. So velocity with no current. So that's the speed the plane would go in still air, plus the velocity of wind or current. All right, so this first example, it says that we have a plane that can travel 100 kilometers per hour in still air. All right, so I'm just going to draw a straight line. It's one-dimensional. So here's a line that represents 100 kilometers per hour. Okay, and that's the speed that this can travel in still air. If it aims upwind into a wind that blows at 20 kilometers per hour west. All right, so it's going upwind, which means the wind is going to be going against it. So, and the wind is 20 kilometers per hour. I don't have my line tool on there. Okay, so something along that length. Now, what we have is essentially we have a plane flying this way at 100 kilometers an hour, wind blowing the opposite direction at 20 kilometers per hour. And we want to figure out the difference between these. All right, we can put this into the formula, actual velocity with respect to the ground. That's what we want to find here. We want to find how fast this plane is actually going. And so actual is going to be equal to velocity with no current, so 100 kilometers per hour, plus the velocity or the wind speed, which is actually, if we put it here, negative 20 kilometers per hour, because it's moving the opposite direction. So plus negative 20 kilometers per hour. We get this net sum, right? Our actual velocity. So if we had somebody on the ground and they had a radar gun and they shot it up at the plane, our actual velocity would be what they read. And so we end up with 80 kilometers per hour, because the wind is blowing against them and slowing them down. That's just the demonstration that example 1 is giving us here.